Hello students, how are you? We again meet for our chemistry science lecture. Now we continue with our chapter 1. In chapter 1 in last lecture we discussed about the type of chemical reactions, right? Different chemical reaction is there. First one is the decomposition reactions, later on combinations reactions, later on displacement reaction, double displacement reaction, oxidation reactions. The combinations reactions and decompositions reactions was already discussed in our last lecture. Now today our target is to complete the remaining 3 reactions: displacement reaction, double displacement reaction and oxidation reaction. So here first one is our displacement reactions. So students, name itself explain what is the meaning of this displacement. Displacement reaction means something is going to displace, means in simple sense, if we want to say, then if any active metal is come in contact with the less active metal solution, then definitely this active metal will displace less active metal from its salt. Displacement reaction means active metal will displace less active metal from its salt. That process is called as a displacement reaction. Here, to understand the displacement reaction, one activity is given. Okay, simple activity is there. Here we will take 2 iron nail, right? Actually in book 3 iron nail is, but there is no need to take the 3. Here we will take the 2 iron nail, and from this 2 iron nail we will hang. Here in picture 2 iron nail is in the hanging conditions. Suppose we assume that we will hang only 1 iron nail, only 1 iron nail that we will hang in the copper solution, copper sulfate solution, CuSO4 solution. It is called as the copper sulfate solutions, and the color of the copper sulfate solution is blue in color. So I will hang 1 iron nail in copper sulfate solution and 1 iron nail aside. Means it is placed as such. We know that when the iron nail is new, on that time is iron nail is in the shining conditions like this. Okay, now whatever the iron nail that is deep into this copper sulfate solutions, slowly the color of the copper sulfate solutions is fading, matlab intensity, blue color intensity is going to decrease. Okay, if we kept for the long period of the time, so definitely it is become colorless. Okay, so here fading of color that we can observe, and we observe that the iron nail is become brown. Now this activity is a displacement reaction. Now how? Here Fe is the iron nail. Now this Fe is dipped into the CuSO4 solutions. Now Cu is weak compared to the Fe, so that's why the Fe is capable to displace the Cu from its salt, means from the CuSO4 solution. So Fe will displace the Cu from the CuSO4, so it will make the FeSO4, and Cu is going to displaced, and that displaced Cu will deposit on surface of iron nail. It is deposit on surface of the iron nail, and color of Cu is brown. So this brown color, brown Cu is deposit on the surface of iron nail, so that's why the iron nail is become brown. Iron nail is become brown, and here FeSO4 solution is formed. So ultimately CuSO4 is converted to the FeSO4, and color, blue color, is a property of the CuSO4. Now CuSO4 is not in existence. Okay, means suppose many quantity of CuSO4 is converted to the FeSO4, so color intensity is slowly decreased. When totally all the CuSO4 is converted into the FeSO4, then color of solutions will become, it is the next stage, color of solutions will become green, because the color of FeSO4 is green in color. But here we place the iron nail for the 2 hours, okay, otherwise the 4 hours. so we observe that the color intensity, blue color intensity is going to decrease. Okay, so this process is called as a displacement reaction. So in this reaction, iron has displaced or removed the another element, that is nothing but the copper. Okay, iron can displace the less active metal only from its salt. In copper is the less active compared to the Fe. Okay, is remove the element, that is the copper, from the copper sulfate solution, and this reaction is known as a displacement reaction. If we talk about the another example, Zn is also active compared to the CuSO4. Pb, lead, is also active compared to the CuSO4 solution. So Zn is capable to displace the Cu from the CuSO4 and make the ZnSO4 and will displace the Cu. Pb is capable to displace the Cu from the CuCl2 solutions and will make the PbCl2 and displace the Cu. So this reaction is called as a displacement reaction. It is known as a displacement reaction. So I think so you understand what is the meaning of displacement reaction. So here in displacement reaction, one component is element and another component is a compound, then displacement reaction is possible. Now what's happen in double displacement reaction? Here double displacement reaction means it is the displacement reaction, but here the displacement of the both the ion is occur, means when both the substance, both the component is a compound form. In displacement reaction, one is in the metal form, means the element form, and second one is in the compound form. Now here both is in the compound form, both are available in the solution form, but both the solutions means both the component is available in the solution form, then the positive ion is also going to displace and negative ion is also going to displace. In displacement reaction only positive ion is going to displace, only positive component is going to displace, but here in the double displacement reaction both the ion is going to displace, and that's why it is called as a double displacement reaction. So here in certain displacement reaction, two different atoms or group of atoms of one substance are displaced by the atoms or group of substance of the another substance, then this reaction should be called as a double displacement reaction. Simple, very simple example is that I will take Na2SO4 solution, that is nothing but the sorry, that is called as a sodium sulfate. This sodium sulfate solutions is mixed with the barium chloride solutions. Now when I mix both the solutions, I observe that the precipitate, white precipitate of barium sulfate is produced, and NaCl that is produced, that is in the dissolved form. So here when we mix these both the solutions, the white precipitate of the barium sulfate are obtained and sodium chloride remain in the solutions. So here this reaction is the example of the double displacement reaction. How? Here we observe that the cation Ba plus 2 of BaCl2 are displaced by the cation Na plus of the Na2SO4 sorry, is displaced by the cation Na plus of Na2SO4, means Na plus 2 displace the Ba plus 2 from the BaCl2 solution. In the same way Cl minus are displaced by the Na2SO4 2 minus, and it will make the BaCl2 from the it will form the BaSO4 from the BaCl2. So Cl minus are displaced by the Na2SO4 2 minus, Na2SO4 2 minus. So in these reactions we observe that both atoms or group, here Cl is the atom and SO4 is the group of atoms, both atoms and group are displaced simultaneously, and hence this one is called as a double displacement reaction. This reaction should be called as a double displacement reactions. Now here insoluble BaSO4 produced, okay, white precipitate of the BaSO4 is produced in this reaction. So this whatever the insoluble substance is there, that is called as a precipitate, that we know that the insoluble substance form is known as a precipitate, and any process, any reaction in which this precipitate is formed, this reaction is also called as a precipitation reaction. Any reaction in which the precipitate is formed, that reaction should be called as a precipitation reaction. So Displacement, as we discussed earlier, displacement reaction are found generally occur in the aqueous solutions of the ionic compound, means to compound form to solutions form is involved in the double displacement reactions. Okay, is involved in the double displacement reaction. Understand? Now we will move to our next reaction. Okay, I think so you are familiar, means you can easily understand what is the displacement reaction and what is the double displacement reaction, and what is the difference between displacement and double displacement reaction. Now next reaction and last reactions of this chapter is the oxidations and reductions reaction. I think so you are familiar with these terms, oxidations and reduction. Here we will just make revisions for this two terminology. Now oxidations means what? Oxidation means any process, any chemical process in which oxygen is going to added or hydrogen is going to removed, then we can say is that component undergo the process is oxidized. We can say that that compound is undergo the oxidation process, otherwise is oxidized. So in any chemical reactions, if oxygen is going to added or hydrogen is going to removed to the element, otherwise molecule or the compound, means component, generally we can call it as a component, then we can say is that component is undergo the oxidation process. Okay, so here Cu is there. When the Cu is burned in presence of oxygen, otherwise we can say is that when Cu is come in contact with the oxygen for the at a higher temperature, then here CuO is formed, that is the copper oxide is formed, means here oxygen is added into the copper. So we can say is that the copper is oxidized. Copper is oxidized, means copper is undergo the oxidation reaction. Okay, so this is about the oxidation reaction. Okay, this is the simple definitions of the oxidations and reductions reactions. Advanced definitions of the oxidations and reduction reactions that you will study in 11-12 standard. Okay, means electron transfer way, okay, oxidations number way, but there is no need to study that concept in the 10th standard. Now second is the reductions reactions, the reactions in which the oxygen is going to removed or hydrogen is going to added, then these reactions should be called as a reductions reactions, and we can say is that compound undergo the reduction process, that compound is reduced. Okay, so the reactions opposite to this, in which the hydrogen is going to added or oxygen is going to removed from element, molecule or compound, then it is called as a reductions reaction. Here copper oxide is taken as a reactant. When the copper oxide is heated with the hydrogen gas, so copper is formed, side by side water molecule is produced. So you observe that from CuO, O is going to remove, O is going to remove, means we can say is that CuO is reduced. We can say is that CuO is reduced and Cu is produced, means oxygen is going to remove from the CuO. So that's why this process means is the example of the reductions reaction. Now this reaction is only reductions reaction? No, definitely not. Always when oxidations occur, side by side reduction is also occur. Oxidations and reductions is the combined process. Always oxidations and reductions is the combined process, and that's why the overall reaction should be called as a redox reaction. Here now see these reactions again. CuO plus H2 gives the Cu plus H2. So you observe that the CuO release the oxygen, and that's why the Cu is undergo the reduction process. But in another way, other side of this reaction, you observe that the H2 is there, hydrogen gas receive the oxygen, so H2 is undergo the reduction process. CuO is undergo the CuO is undergo the reduction process, and H2 receive the oxygen, and that's why the H2 is undergo the oxidation process. So here reductions as well as oxidation both is occur, and that's why this reaction should be called as a redox reaction. This reaction should be called as a redox reaction. During this reaction, here the same discussions is given. During this reaction, the copper oxide is losing the oxygen, so it is being reduced, and hydrogen is gaining the oxygen, so is being oxidized. So in simple way we can say is that the one reactant get oxidized while other will definitely reduced during the reactions, and such reactions is called as oxidations reductions reactions, and it is also called as a redox reactions. Means hydrogen is undergo the oxidation process and copper oxide is undergo the reduction process. So CuO to Cu is the reduction process, and H2 to H2O is the oxidation process. Sorry. Another example is that is the ZNO plus carbon gives the Zn plus CO. So ZNO is undergo the reduction process, while carbon to carbon monoxide is the oxidation process. Okay, in the same way MnO2 to MnCl2 is the reduction process, and HCl to H2O is the oxidation process. This one is the reduction process, and this one is oxidation process. Okay, so here we observe that when any oxidation reactions is occur, side by side reduction reaction is also occur. So this whole reactions combinedly called as a redox reactions, otherwise oxidation reduction reaction. Now what is the importance of this oxidation reduction reaction? So here two important two natural oxidation reduction reaction is there, and it can harm to very high level to our economy, to our society. Two reaction is there. One is the corrosions, and second one is the second one is the rancidity. Okay, corrosions and rancidity. Now you are familiar with this term corrosions. It is corrosions of the iron is also called as a rusting process, right? So when any metal, active metal, iron is there, copper is there, silver is there, okay, it is come in contact with the environment in the presence of moisture, so definitely that compound is undergo the corrosion process. Suppose if I place the iron in the environment presence of the moisture, so it will be converted into the iron oxide, it will be converted into the iron oxide, and that process is called as a rusting of iron. That is called as a rusting of iron. So here simply due to this rusting, that iron strength is going to decrease. Due to rusting of iron, iron strength is going to decrease. So whatever the means iron that we use for the construction purpose, for the constructions of the bridge, for the car body bridge, iron railing, ship, this all the object, okay, different object, okay, we know that iron is used now everywhere. So this all the iron, if it is not protected, if it is not protected from the corrosion process, so definitely this iron is undergo the corrosion process, and due to that it is it is harmful for our society. Suppose the bridge is there, suppose the building is there, if the iron is undergo the construction purpose, iron is undergo the corrosion rusting process, so ultimately there is a chances of breakage of bridge, otherwise the constructions is become weak, so it may harmful to the society, okay, and economy, it may harm to the economy also. So that's why we can say is that the corrosions of the iron is a serious problem. Another example is the black coating of the silver. Okay, when we use the silver, we observe that after long period of the time the silver is converted into the black color, black coat that is generated on the surface of the silver. It is also the corrosion process. Green coating is done on the surface of the copper is there, okay, when the copper placed for the long period, green coat is generated, okay, it is also the example of the corrosion. So corrosions is harmful, it is a serious problem, it is harmful to the for every case. So there is need to prevent the corrosions. Okay, the step for the prevention of the corrosions that we will discuss in the chapter 2. We will discuss this corrosion in detail in the chapter 2, how the corrosions is occur, which mechanism means which process is occur in the corrosion, and how we can prevent the corrosion process. These all the things that we will discuss in chapter 2. Now second topic, second oxidation reduction reaction example, that is the rancidity. Any fat is there, oil is there, okay, when is oxidized, then we can say is that it is rancid, and due to that bad smell is generated. Bad smell is generated. So whatever the food material is there, they contain the fat or oily component. So when it is placed for the long period of the time, we feel that the bad smell is generated from that food material. Okay, so it is nothing but the rancidity process. It is the oxidation process. That food material is oxidized, and that's why the bad smell is generated from that food material. So the substance that is added into the food material that prevent the oxidation is called as an antioxidant. So many antioxidant is required to be added into the ready-made pack, means whatever the ready-made food material is available. Okay, even ready-made what we can say drink are available. Okay, maza is there, and that also the antioxidant is required to be added. Many what we can say is pickles is there, in which there is need to add the antioxidant. So different food material, okay, in which there is need to add the antioxidant just to prevent the oxidations of that food material. Okay, the best example is chips, potato chips, bala chip. Okay, many other potato chips are available, it is just one example. The bala chips is there. You observe that when you purchase that chips, okay, the packet is full of air. Okay, means you feel that the air is filled into that chips. Why? Because that air is nothing but the nitrogen. So when the chips are undergo the packing process, on that time the flux of nitrogen, means the nitrogen gas is passed. So this all the means total packet is filled with the nitrogen, and nitrogen, in the presence of nitrogen, the oxidations will be prevented. So here usually flush the bag of chips with the gas such as the nitrogen to prevent the chips from getting oxidized. Why? Because the nitrogen is available, definitely oxygen is not available. Nitrogen is heavy compared to the oxygen, so your bag is completely filled with the nitrogen, so chips is not undergo the oxidation process. Ultimately chips remain protected for the long period of the time. So this type of chips is healthy. If you purchase the Balaji chips or any other chips in which the gas is not filled, so definitely this chips is not suitable for the health, is not healthy food. Understand? So this is about the rancidity process. It is also one example of the oxidation reduction reaction. So students, today we discuss the three reactions. One is the displacement reaction, second one is the double displacement reaction, and third one is the oxidation reduction reactions. Now today our chapter 1 is officially completed. Now if any doubt, you can communicate on WhatsApp. Okay, thank you very much.